Okay, so what we're going to talk about is oxidation number. And oxidation number is essentially the effective charge on an element once it's gained or lost a few electrons. But first of all, let's even find out how we find out the charge of an element. It's actually really simple. We're going to look at sodium. Sodium, Na, has 11 protons and 11 electrons when it is neutral. And how can we even check that this is neutral? You have to remember that every proton has a positive charge and every electron has a negative charge. So if we add together all the positive charges and negative charges, we have 11 protons plus 11 electrons. And do you notice something that I put a little negative in front of here? This little negative signifies the negative charge, because if not, we're going to have sodium with a charge of 22, and that's way too big. We want to, normally sodium when it's neutral has a charge of 0. So if we do 11 minus 11, which we have here, sodium has a charge of 0. Now, sodium has a very low oxidation number, and that means that sodium likes to give away this last little electron that it has over here. It likes to give it away. So what it does is, when it gives it away, sodium has one less electron than it had before. So sodium will now have 11 protons. Actually, let's write that in red so that we know there was a change. 11 protons and 10 electrons. So if we do the same equation, the one that we found right here, we find out that sodium has 11 minus 10, a charge of positive 1. This charge of positive 1 means that sodium can basically bond with anything with a negative charge, because that effective charge is actually what pulls together elements such as these. So let's take a look at that. Let's make these guys tiny and hide them away. Let's bring this back over here. So, sodium. Sodium is right here, Na, and I wrote it with all of its electrons because that actually makes it much easier for us to see. This last electron is the important one that we're looking at. Sodium likes to give away this electron to elements with higher electronegativity, such as chlorine, and make itself feel like if it's a noble gas. It feels like if it's a noble gas because if this electron is gone, if we made it disappear, sodium now has 1, 2, 3, 4, 5, 6, 7, 8 electrons just like a noble gas, and it makes it much more stable. So normally what happens is that sodium gives away this electron, chlorine takes it up, and sodium gains a positive charge, just like we saw up over in this little work right here. However, what happens to chlorine? Chlorine has to gain a charge too because it's gained a difference of electrons. So now chlorine, we know it has 17 protons, but how many electrons does it have? Now if we actually added these up, we'd see that sodium had 18 electrons. So let's solve for what chlorine's charge is again. Sorry, I was saying sodium, I meant chlorine. So chlorine, after sodium gives up its electron, has 17 protons, 18 electrons. So 17 protons, they're all positive charged. 18 electrons, they're all negatively charged. And to solve again, we have 17 plus negative 18, and that makes a negative 1 charge. And to find out that negative 1 charge, we just zoom in over here. Let's move that out of the way. Zoom in over here. And now chlorine has a negative 1 charge. So sodium with a positive charge and chlorine with a negative charge. And what's that term that we knew before? Opposites attract. So the force from the sodium and the chlorine bring them together, and we make a type of bond which is called an ionic bond. And that ionic bond is actually from the attractive force between the different charges. Next, we're going to talk about where we actually find the oxidation numbers of elements on the periodic table. Okay, so here we have the periodic table, and we're just going to find the oxidation number of elements. And the easiest way, actually, where we can explain the oxidation number of elements is through their Lewis dot structure. So if you remember the Lewis dots, they look something like this. So this row normally has 1, 2, 3, 4, 5, 6, 7, 8, except for helium. This row has 1, 2, 3, 4, 5, 6, 7. This row has 1, 2, 3, 4, 5, 6. This row has 1, 2, 3, 4, 5. Actually, I drew that wrong. Let's redraw that. So it has 1, 2, 3, 4, 5. This row has 1, 2, 3, 4. This column, I kept saying row 1, 2, 3. This column has 1, 2. This column has 1. So, if you look at the number of Lewis dots on the outside of each shell, you can sort of get an idea of what the oxidation number is going to be. The oxidation number, if it's on this half of the periodic table, so anything over here, is going to be positive because these elements have low electronegativities, meaning they like to give away their electrons. On the other hand, if it's on this half, it will very likely have a negative oxidation number because it likes to take electrons, meaning it'll have more electrons than protons. And it's actually really simple what the oxidation numbers are. If you're in the first column of the periodic table, this column right here, the oxidation number will be, let me just pick a nice color, plus 1. If you're in the second column, plus 2. You skip the middle. There are oxidation numbers in here, and we can talk about them later, but for now you don't have to worry about them because some of these elements have variable oxidation numbers, and normally you'll be given the oxidation number in one way, shape, or form if you ever have to make a bond with these. And then you continue your little trend that we started over here, right here in boron's column, and boron's column has a plus 3 oxidation number. We're going to skip carbons for now, and let's go and start all the way from fluorine. Fluorine's column is actually the first column with a negative oxidation number. So this has a negative 1 oxidation number, because as you can see, if you look at the Lewis dot structure, it only needs 1 more to fill up its outer shell. And then oxygen will have a negative 2, and nitrogen will have a negative 3. Now let's get back to this column, the carbon column. This column normally isn't treated like it has an oxidation number because it can actually have an oxidation number of what we would call plus or minus 4. Plus or minus 4 because, actually let me rewrite that because it's kind of ugly. Plus or minus 4. Plus or minus 4 because these guys' electronegativity is somewhere in the middle. And because of that, they can either gain electrons or give away electrons to fill up their outer shell. Normally, these guys like to form covalent bonds, especially carbon. Carbon is what makes up our body, and it forms a lot of covalent bonds that make a lot of the chemical compounds. So if you want to remember this simply, to find the oxidation number, just look at the column that the element is in, and then that column, if it's from the left, it'll have plus 1, plus 2, plus 3. You stop at plus 3. And then if it starts from the right, it'll have minus 1, minus 2, minus 3, each column subsequently. Okay? And that's ionic bonding and oxidation numbers. Next video, we'll go into detail about actually making ionic bonds.